Welcome and aloha from Hawaii. In this 20-minute presentation, I'm going to show you some empirical evidence that suggests that the shape of the Earth, as we've been taught, is incorrect and does not hold up to what you can actually see with your own eyes, both photographically as well as technically. I'm going to show you clear images of Oahu from Kauai, an island that's more than 90 miles away that really should not be visible if the Earth is indeed a sphere. Then I'm going to take you to a perfectly proportionate model of the spherical Earth so you can see what's wrong with this picture. And after you look at all the evidence, you too can decide for yourself if the Earth is really flat. Hi everybody. You know, I live on Kauai, and about 6 months ago, started noticing on YouTube all this activity around the subject of the flat Earth. Now initially, it seemed very strange to me that, there's hardly ever anything about flat Earth. In fact, I had no interest at all on that subject, and all of a sudden, not just one or two videos, but literally hundreds and maybe now like thousands. So what's happened? Why do we have all these flat Earth videos? Well, apparently it started with Eric Dubé's book that he released back in November. There were individuals before this, but it wasn't much of a topic. So once Eric Dubé put out his book, November of last year, 2014, it seems like it just took off like, it's like madness. And when I discovered this, I think it was May or June, I spent a whole week just going through videos trying to digest all this information. And within that time, I was pretty certain that there's something to this. So I wanted to add my own bit of truth to this movement, and I live on the island of Kauai. And I've always heard stories that you could see Oahu from here, which is, depending on who you ask, anywhere from about 70 miles to over 100 miles away. And so technically, you really should not be able to see an island that far away due to the supposed curvature of the Earth. So I've been waiting and waiting and waiting for a very clear day so that I could get a picture of Oahu from Kauai. Now, what you're seeing on the screen right now is a picture I found online that was taken back in, I believe, 2005. And it's taken kind of looking over Lahui. I don't know what the elevation is, probably at least 200 or 300 feet, maybe less. And you can clearly see Oahu off in the distance. Now, I've had this video, I've had this image, and I thought about making a video before, but I thought, no, I want to get my own image. So just the other day, on the 25th of October, 2015, we had a pretty clear day, and I was able to get several different shots of Oahu. So the one that I got first was early in the morning, and it's not the greatest picture, but knowing what I'm looking for, it was clear to me that this was Oahu. And you can see the clouds, and then you can see the island formation right below that. Later in the day, I've got this image. Now, this image is a little better. You can clearly see the outline of a landmass that is approximately 100 miles away. It's not a mirage, it's not clouds, it's clearly a landmass, and it in fact is Oahu. Here's an enhanced version of that same image. I've tried to increase the contrast so that you can make out the landmass even better, and I've also zoomed in. There's also an image that was taken from the airport, and the elevation here is probably less than 50 feet off sea level. This image is taken when the sun was coming up behind Oahu, which probably helped to be able to see the image. So to further add to this whole thing, there's this website called TripAdvisor.com, and I did a search for being able to see Oahu from Kauai. And lo and behold, on January 19th, 2011, there were reports that people were seeing Oahu from different points on the island. This one here, it says, yes, sky, air, and sunlight conditions have been perfect to view Oahu and the horizon a mere 105 miles away, spotted from vantages on the east side, including Opika'a Falls, the Wailua River outlook at the base of Kuamu'u Road, where it meets Kuhio Highway, and even from Baby Beach. So you can see it at sea level. And there's many, many different people that wrote in with accounts of being able to see Oahu. So, this brings up a point. If the Earth is in fact a sphere, like they tell us it is, how come you can see Oahu? How come you can see this landmass, which, by the way, its highest point is just a little over 4,000 feet. I think it's 4,025 feet. It's Mount Ka'ala. And Mount Ka'ala on Oahu should be well below the horizon, or at least, maybe you can see the very tip of it if you were, at the right vantage point. But ultimately, you should not be able to see Oahu because it would be below the horizon. So to illustrate that, what I did was, first of all, let me show you. This is what Google says. You did a search distance between Oahu and Kauai. They say it's 108 miles from the center of Kauai to the center of Oahu. So, Google said it, it's official. Anyway, I created a little graphic. Here's the Earth, as they tell us it looks. And we're going to get rid of the Earth here. We're going to replace it with a protractor. Now, the Earth is made up, if you want to go in a circle, it's 360 degrees. So on this protractor, every one of those marks that go around the circle is 1 degree of arc. And there's a total of 360 of those marks, or spaces. So that makes 360 degrees. So what I did was, just give me a moment here. Let me just click on it. There we go. Okay, I'm going to zoom in. Now remember, this is the Earth. It's 24,000, almost 25,000 miles in circumference, according to what scientists tell us. So this is a real easy calculation. We're using minimal math because there's been a lot of debate as to just how you calculate curvature of Earth. So what I've done is I've created a mechanical drawing that is actually proportionate. So I've got the entire Earth right here on your screen, and what I've done is I'm going to get rid of the protractor. We're going to zoom in. Now hopefully you can see these lines here because I'm using the most narrowest lines that are available in this program because lines have thickness. So this graphic is extremely accurate. It basically, I've been able to zoom in to the Earth itself. Here's Kauai, which is the island that I'm on. Here's Oahu. Now, remember, Google says that it's 108 miles between Kauai and Oahu. So, to back up a little bit, the circumference of the Earth is 24,901 miles. Now, that number might vary a little bit between different sources. I've seen it just estimated to be a flat 25,000 miles, and I've seen it a little less. But 24,901 is the most common number. So what I did is I divided that number by 360 degrees so that I could figure out how many miles are in each degree of arc. So remember, just to go back a little bit here, here's the picture of the Earth. Put the Earth back. Okay, so here's our Earth, 24,901 miles in circumference. That means that's the distance all the way around it, if you were to go all the way around the spherical Earth. Okay, get rid of that. We're going to put our protractor back again. Okay, now at the very center of this protractor is the center of the Earth. And you'll notice the rectangle with the little blue dot in the middle of the rectangle. That is not the center of the Earth, that's the center of the rectangle. That's just so that I have something to click on so that I can easily access the center without having to hunt for it. So as I zoom in as far as I can go, you'll see these red lines up here. These are each degrees of arc. This one is at 91 degrees. This one is at 90 degrees, which is exactly vertical. This one is 89 degrees, and this is 88 degrees. You notice how they all originate at the very center of the protractor, which is the center of the Earth in this model. Okay, so as we zoom in, you'll see these lines cut right through the protractor. Once again, we have 91 degrees, 90 degrees, 89 degrees, and 88 degrees. Okay, so remember our math here. 24,901 miles divided by 360 degrees equals 69.17 miles per each degree of arc. From this point here to this point here is exactly 69.17 miles. Now, I could have made this circle any size because what I'm really interested in is determining just how big this is. Okay, so what I did was I created this ruler in this program. I knew that from this point to this point is exactly 69.17 miles because this is 1 degree of arc. So what I did is I created my ruler and then I sized it accordingly. So I sized it so that it would be exactly 69.17 miles. So you can see that's how we got the proportions. The size of Kauai and the size of Oahu are also proportionate according to this ruler. So, and there's also 108 miles here. That is proportionate. Everything here is proportionate. Here is the surface of the Earth. In this case, we're dealing with water. Now the red line right here, the red line, which is a horizontal line, I'm going to back up a few steps. This red line is perfectly horizontal. So this represents what you would be able to see if you're looking across the horizon. If you're looking out at the ocean, you're looking at the horizon line, you are seeing a line that is completely horizontal. And I'm going to zoom back in. Here's the red line I'm talking about. So if I'm sitting right here taking a picture of Oahu, you know, there's a fair amount of ocean where it appears flat and then it just drops off. You just can't see any further. The eye can only see so far. Even if you have a telescope, you can see things that are further in the air, but as far as the ocean, there's only so much ocean you can see. So I've set this up so that to estimate the line of sight. Now the line of sight takes us right to the very top of Mount Kauai, which is a little over 4,000 feet in elevation. So like I'm saying, if you were up a little bit in elevation, technically you ought to be able to see the very, very tippy top of that. If you're down at sea level, probably not. Now this is on a round Earth, of course, a round Earth model. So the big rub I have here is that you should not be able to see this landmass. Not unless you're up sufficiently high, like thousands of feet, would you be able to see that landmass. You would not be able to see it at sea level or 100 or 200 feet off the ground. You just wouldn't be there. And yet, the evidence is overwhelming. You know, we've got people here saying that they've seen Oahu. Not just one, but several. And then we've got this one here. This was taken at the airport. And then we have this one that I just took recently. Clearly see Oahu. There's the definition and the outline of this landmass. We're not just seeing the tippy top. We are seeing the whole thing. This one is not quite as good. There's actually some clouds in the way, so it actually kind of goes up here a little bit more. And then we have the original one I found. So once again, there's some clouds that are covering Kauai. But you can pretty much see the whole thing. This is not just a tippy top. So this brings me to the point that instead of looking at it like this, where you have the curvature of the Earth, remember, oops, here's the Earth, here's our curve. This picture of the Earth. Here's our protractor. Remember, 360 degrees. Each one of those degrees equals 69.17 miles. So we can zoom in a perfectly proportionate Earth, actually see what it all looks like. So anyway, this is what everyone tells us, or this is what the accepted theory is right now, that we are on a curved surface. And the fact that we're on a curved surface, you should not be able to see that landmass. So why can I see it? There's actually a newspaper article from September 25th, 2011. It says, clear to Oahu. Weather conditions gave Kauaians a rare treat Wednesday morning with a clear view of Oahu some 90 miles away. So you can clearly see the image or the outline of the island here at the bottom of the frame. I believe this was taken at sea level, and also that it was taken during high tide. So you're unable to see this one little portion here, but other than that, the outline is exactly the same as what is in all the other images that I've collected. So, is it possible that we are not on a spherical planet, but instead on a flat plane? Here's another image, way back from over 100 years ago. It's showing the continents on a flat plane, and it's showing the Antarctic continent actually as an ice wall around the perimeter. There's a picture of that ice wall that seems to go on and on and on and on forever. Now I know this flies right in the face of everything that you probably believe, unless you've been already watching a lot of these videos on YouTube about the flat Earth. Now, I'm not going to try to convince you one way or the other in this video. I'm just trying to give you some evidence that I have found, and I'm going to let you decide what you think. But from what I can, what I can tell here, there's something here that you can't ignore. Okay, here's another interesting factoid. The United Nations uses the flat Earth map on their flag. The flat Earth map is also known as the azimuthal equidistant projection, and it's the same projection that the USGS also uses. USGS, the United States Geologic Survey, is sometimes referred to as the map makers of the world, so you'd think they'd want to have an accurate map. And once again, the United Nations is using the same exact map. So maybe they know something that they're not sharing with the rest of us. So in conclusion, it seems to me that this model is really doesn't hold up here. We have empirical evidence. We have multiple images of Oahu clearly seen from Kauai, different people, different dates. You can see the entire landmass. You should not be able to see that landmass based on the curvature or the Glober theory that says the circumference of the Earth is 24,901 miles. It should be below the horizon unless you're up, at least probably at least 1,000 feet, I would think. But yet you can see it at sea level. So I think that maybe this is a better way of looking at it. You have Kauai here, you have Oahu there. It's completely flat, and yes, sometimes the tides might affect the ocean a little bit, but we're not dealing with a curved surface, we're dealing with a flat surface. So I'll leave everyone here with these facts to contemplate, and you guys can make up your own mind.